Hi friends, in this video we are going to discuss about the demodulation of the FM. For that we use the slope detector. Slope detector is a circuit in which we give as an input our resultant frequency modulated signal to the frequency selective circuit that is followed by the envelope detector, and we got our message signal as the output. Now we replace block diagram with a basic circuit diagram. Frequency selective circuit is a tuned circuit that is followed by the envelope detector. Envelope detector is same as we discussed earlier in the demodulation of the amplitude modulated signal. We assume that the resonant frequency of this tuned circuit is 1600 kHz. As we seeing in the diagram that tuned circuit consists of two inductor which forms a transformer. Diagram of the bell shape shows the basic characteristics of the tuned circuit, in which we plot the gain versus frequency curve. The frequency is in the range of kilohertz. For the tuned circuit, we assume that the resonant frequency is 1600 kilohertz. So, at this frequency, gain of the circuit of the tuned circuit is maximum. Let we assume that as a 1. 1400 and 200 are the some assumed frequency that we discuss in this video for our further discussion. Let assume in the wave 1 we have given some message signal of this form, and in the second form we have a carrier signal which has the amplitude of the 10 volt. So as we know, in the frequency modulated signal, the the frequency of the carrier will change according to the message signal amplitude. So in the A area, the message amplitude is higher than that of the B, because 7 volt is greater than 1 volt. So in the A area, frequency of the carrier will increase. So in the area A, there are so many terms of frequency in comparison of the carrier signal, and in the B area the message signal amplitude decreases. So the in the third wave, carrier signal frequency will be decreased. So we assume that the signal completes only one cycle. Frequency is the number of cycles, so frequency decrease, so here it completes only one cycle. In the C area, further the message signal amplitude increases. So here again carrier frequency will increase. So the resultant frequency modulated signal is shown in the figure 3. In this figure, it is clear that the resultant frequency modulated signal passes through the frequency selective circuit. So the third wave is multiplied by the gain characteristics of the tuned circuit. In the resultant frequency modulated signal, let assume that the high frequency is given by the 14 kHz and the low frequency is given by the 200 kHz. So at 14 kHz, gain in the gain characteristic, amplitude value is given by 0.7. So we know that the carrier signal amplitude is 10, as we know that in the frequency modulated signal, amplitude of the signal of the carrier will not change. So the resultant frequency modulated signal amplitude is same as the 10 volt. So 10 when 10 multiplied by the 0.7, resultant amplitude of frequency selective circuit is as a 7. And for the 200 kilohertz, the gain characteristic amplitude is given by 0.2. This 0.7 and the 0.2 are some assumed value. So when 10 multiplied by 0.2, the resultant amplitude after the tuned circuit for the 200 kilohertz is 2. So in this manner we obtain our signal. Resultant of the frequency tuned circuit passes through the envelope detector, and as we discussed earlier, that the envelope detector detects the positive peaks of our signal. So it detects the peak of our resultant signal that is shown in the figure 4. So our resultant signal after the envelope detector is like that is shown in the figure 5. This pink line is detected by the envelope detector. or the positive peaks of our resultant signal that is passed through the frequency selective circuit. And in this manner we recover our message signal from the frequency modulated signal. But this circuit has a problem because the gain of the tune circuit is assumed by the us, or it is manufactured by the manufacturing unit, so it will vary, or it's a nonlinear gain. So in the resultant message signal, amplitude will vary from our basic message signal. So in this way we have a message error, we have a error in the message, so that is called as a slope error, that is recovered in the balance slope detector. And second problem in the slope detector is that we use the transformer in the tune circuit. As we know that the transformer are the bulky and the expensive, so these days these circuits will not be recommended. Today we use the PLL, that is called as the phase looped loop, that we discuss in the next video.